Hello, good evening. Thank you for joining us for Group 9's project presentation. Today we'll be discussing a problem of assisting a sibling for financial planning. So the setup is that your sibling has come upon a large sum of money and you've been asked to efficiently perform a one-time bond distribution of her new assets. So you want to sustain her cost of living for the next 10 years as well as maximize the leftover profit which you end up getting at the end of that period. So with a series of givens, we're often ready to start the problem. So we want to know for a project objective how many of each bond we must purchase in order to maximize the share at the end of the 10-year period. In addition, we'll be evaluating the interest rate at which you might change the breakdown of investments.
All right, so here I'm going to discuss the tools that we use to solve this problem. So as our objective, we wanted to maximize the amount of profit available at the end of the 10-year period. And then we had a set of decision variables, which were 1-year, 3-year, 5-year, and 10-year bond. And we wanted to see how many of each bond we were going to purchase to maximize our objective. With that, we had parameters, $300,000 startup for the investment over a 10-year period, with a cost for each one of the bonds, as you can see, and then a 3% return interest rate. And we also had a set of constraints.
Before anything else, you certainly want to go ahead and plan out the problem. So by drawing it out and creating a diagram, this allows you to be better prepared to address the objectives in the problem. And there's multiple ways to do that. As you can see, it's another way to visualize our problem.
All right, so now I'm going to take us into Excel and go through the analytics solver and what we did here. So I'm just going to run the analytics solver right now. And as we can see, here we ran a network model. We have clear constraints for our model, and we also have listed all the cash flows for each year. As we can see in green, here are decision variables and how many of each bond that we are purchasing in order to maximize at the end of 10 years. And our objective, we got 71,143. And then moving on to answer the third question on finding the minimum interest rate that would alter the 4 types of bonds, we created the same network model, but for the return, we created a psi-op param for 0.03%, and with this, we are allowed to run an analysis report. And with that, we concluded that with 0.037% is the minimum interest rate that would alter the 4 types of bonds. So with that, answering the questions that we discussed previously, the amount of bonds that were purchased after we ran the solver, the objective, 71,142.51, then answering question 3 with 3.7% interest rate.
So as you can see, in guiding your sister's investment strategy, these are the results that we came up with when looking at just the bonds that were purchased initially at the beginning of right after she obtained her winnings. Now, if we took it a step further, we decided to explore some what-if scenarios. So beyond the constraints, we're looking at the scenario of perhaps foregoing that first year of cost of living. People often jump into a lottery winning, and they don't stop to think how to invest appropriately. So if she foregoes, let's say, the first year of her winnings, she'd have an additional $50,000 in her pocket. The next scenario that we evaluated was, what if she just spent half the amount that she was anticipating? If she was able to maintain a frugal lifestyle and maintain that over the next 10 years, we determined that she would actually make out pretty much even. She'd be at $300,000, which is what she started with, which is pretty great. And lastly, we evaluated the cutoff point at which bonds were no longer viable and interest rate was actually a smarter way of investing money. So at 6.3%, bonds are no longer viable or beneficial for you to invest your money in. So for this particular model, that's where we'd say you can stop and just ride the interest. And those are the constraints visualized.